Hi guys, today we're doing minimum operations to Halve Array Sum. So we're given an array called nums of positive integers. In one operation, we can choose any number from nums and reduce it to exactly half the number. They say note that you may use this reduced number in future operations. And they want us to return the minimum number of operations to reduce the sum of nums by at least half. So in example 1, we're given nums equals this array as our input, and we would return 3 because the initial sum of nums is 5 plus 19 plus 8 plus 1, which is 33. And they say the following is one of the ways to reduce the sum by at least half. So first they pick 19 and reduce it to 9.5 because that's half of 19. Then they pick 9.5 and reduce it in half to 4.75. And then they pick 8 and reduce it in half to 4. So then this is the final array after we have halved those numbers. And the new sum is 14.75, which is less than or equal to the original sum of 33. So since we did all of this in 3 operations, then we return 3. In example 2, we get this input array, and we would also return 3 because the initial sum is 31. And then they start by having 20 to 10, and then 10 to 5, and then 3 to 1.5. So the new sum is 14.5, which is less than or equal to 30 or half of 31, which is the original sum. And because we did this in 3 operations, we would return 3. So basically, if we think about what we're doing here, so we're always picking the biggest number in the array. So we, like in example 1, we start with 19. In example 2, we start with 20 because those are the biggest numbers, right? Because if we pick the biggest number to start with every time, then that's how we can guarantee the minimum number of operations to have it before our sum is half of what it originally was. Does that make sense? So every time we're going to pick the biggest number that is available to us. So if we take a look at like example 1, so like let's say we sort this, and I'm just going to do this so that it's pretty easy to see what's going on. But basically, like if we always pick the number in like the biggest number, right? So we start with 19 and then we half 19, then we get 9.5, and then then this becomes 9.5, and then we could say like the number of operations is now 1. It would have started at 0, I guess. So then we have 9.5, and then we also need to keep track of the sum. So the original sum was 33, but now since we just took off 9.5, then 33 minus 9.5 would give us 23.5. So then we get 23.5 for our new sum. And the operations is 1. Yeah, so then the next round, then we take the biggest number, and this is still not half of what it originally was because it was 33. And so half of 33 would be 16.5. So we need to go until we at least have 16.5 or less. So then we pick the next number, which is 9.5, because that's the next biggest one. We half that, which is 4.75. And then, gosh, this is like too much math for me, guys. So I'm just gonna do the math on my calculator as we go because I don't want to mess this up. But 23.5 minus 4.75, so we take that off of the sum, which gives us 18.75. And then the operations becomes 2. And then okay, so then to maintain the sorted property, we can move this over here. So then, this is still greater than the half of the original sum, because the half of the original sum was 16.5. So we're going to keep going. So then now our next maximum in our sorted array is going to be 8. So to half that, we would get 4. And then to take 4 off of 18.75 would be 14.75. And then our operations goes to 3. And now our sum is less than or equal to half of the original sum, which is 16.5. So we can stop here, and then we would just return the number of operations that we used in doing that, which is 3. So that's sort of how our algorithm is going to work. And so now let's start actually doing it. So to maintain like the sorted property, we're going to use a priority queue, and it's going to be a max heap. So we're going to do the reverse order thing again. So we're going to say priority queue of, and we're actually going to do doubles because we're working with doubles here since there's like a lot of division and stuff going on. So we'll say heap is new priority queue. And then we'll do the comparator dot reverse order. And then we will initialize our sum to 0. And then we're going to loop through nums to calculate the sum. So we're going to say for double num in nums. Then we are going to, first of all, we're going to add it to the sum. But we also want to add it to the heap. So then our heap will just store all the same numbers that are in nums, but it'll it will always be able to access the maximum every time this way. So then once that is done, we will have our max easily accessible. And then we also want to, so I'm going to say initialize another variable for half of the sum, so that when we do our loop, like our while loop, until we get half of the sum, then I can just use this variable. So we can say half is sum divided by 2. So if our sum is 33, then half would be 16.5. Okay, and then I will say int operations is 0, because we start this at 0, and then every time we do an operation, we're going to increment it. So while sum is greater than half, then we're going to decrement sum by half of the number that we are having. So we're going to take off the maximum from the heap. So we'll say top is heap.remove. So initially our max is 19. So it starts off as 19. And let's put this back into what it originally was, just so we can see what is going on. And again, this is not even how a heap is actually represented as, but I'm just doing this like for simplicity of explaining the problem. But just keep that in mind, because I don't want to like confuse you guys even more. So then we'll say the divided is top divided by 2. So this would be like, once we divide this number, which is our maximum, then that will be the amount that we want to add back into the heap and subtract from our sum, right? So this is going to be 9.5. Okay, and then so we took this off of the heap, so now this is gone, the 19, and then we want to add that back. So we will add that back, but we're going to add the one that was divided by 2, which is 9.5. So then once we add 9.5, it's going to maintain the maximum in the front, so it's going to be like this. And then we also want to subtract it from the sum. So our sum is now, gosh, this one has so much like math involved, but so 33 minus 9.5, 23.5. So our new sum is going to be 23.5. And then we also want to increment operations because we just did one round of this, right? And so now operations is going to be 1. So then this is going to continue until we get our sum at least as small as half of the original sum, and then we'll exit this loop. So once we got to 14.75, for example, 1, and then once we did all that, we will just return operations. So let's check that. And then, okay, so then our time complexity is going to be, so like when we think about this, so we have a few things going on here, right? So we start by looping through nums, and adding to sum, which is kind of negligible, I guess. Well, it's like O of n, because we are processing n elements where n is the number of numbers, I guess, or elements that we have in nums. And then we are adding each number to the heap. So if you guys remember, adding an element into a heap is going to be log n time, so that it can maintain the maximum in the front in this case, right, because it's a max heap. But we're doing that for n elements. So it's going to be n log n in this case. So this is n log n. Okay, and then if we move on, then this while loop, if we think about how much this is being processed, so we have a remove here in the heap, which is going to be log n time for each element. This is constant because it's just a division. This is also log n because we're adding something back into the heap. And then this is constant, this is constant. So this is log n, but we are doing this for essentially like, not exactly n, but it's like proportional to n. So it's like technically simplified also to n log n. And then that is it, and this is constant. So our runtime here is going to be O of n log n, where n is the number of elements in our nums array. And then if we take a look at the space complexity, so we only have our heap here, that is our only data structure, and that is storing n elements as well, because we add all of our elements here into the heap from this loop, which is n, because we're adding every single element exactly one time. And then in here, like we do some removals and additions, but every time we remove, we add another number. So this kind of like cancels out, right? Because like every time we remove one, we add another one, then it's not really adding anything. So then we still would just end up with O of n from this loop of adding all the elements in nums into the heap. So our space complexity is just going to be O of n, where n is the number of, sorry, apparently I can't type today, where n is the number of elements in nums. And so that is it for this problem. Thank you guys for watching. If you found it helpful, please like and subscribe, and I'll see you next time. Bye!